I am John DeHart. I'm from Washington University, and I'm going to be doing some NDN demonstrations. But before we get into that, I came up with a new thing that NDN stands for. It stands for Night During Noontime. So, as I said, I'm from St. Louis, which was part of the path of totality today. But I'm here with you where we only got 60% of the eclipse. But this is what my family saw today when they went out to see the eclipse. So they did have clear skies and they got to see totality in the St. Louis area. So if you can't remember name data networking, remember night during noontime. And that's what we had today. Okay, so in my demonstrations I'm going to use several platforms. Hopefully I'll be using the NDN Testbed. I'll be using the Open Network Lab, which Alex mentioned a little bit about, and I'll say a few more words about. I'm going to be using Amazon AWS to add some end hosts to the NDN Testbed to be able to test it in a little more at a little more scale. Some of the topics that we're going to be covering with these demonstrations: NDN topics, producers and consumers, which Baishuan talked about this morning, caching, validation, adaptive forwarding, and we're going to show NDN operating over intermittent links. So the NDN testbed, as Alex mentioned, currently has 37 nodes on 4 continents and 15 countries. There are 32 universities and academic institutions that participate, 4 companies, and 1 government agency. If your organization is interested in joining, the information is on the namedata.net website, and you can find out what the policies and procedures are for joining it. If your site does not want to join, so joining means your site provides a machine that is dedicated to acting as a gateway router for the testbed. If your site is not interested in doing that, as Alex said, you can still use the testbed, and there's again information for how to run NFD, how to connect to the testbed and use the testbed for your testing. And again, as always, stop me if you have questions as we go. So the Open Network Lab is a remotely accessible network testbed that we run at Washington University. It's in the Applied Research Lab where I work. It is real hardware for running repeatable network experiments with trusted results. So trusted results in that it is actual hardware, actual interconnected with networking, so that you can run experiments that you can get results on. This is just a picture of some of the racks in our machine room that comprise some of the machines in ONL. So what we use this for NDN, as well as running demonstrations like I'm going to show you in a few minutes, we have NDN installed on all the machines and all the VMs in ONL. We do NFD performance studies. We do testbed emulation. So before I release a new version of NFD or the routing protocols on the testbed, I'll typically test it out in ONL first to see how it works. So I have a topology that I can emulate the full testbed and see how things are going to work. If you're interested in using ONL, you just go to onl.westedal.edu and get an account, and then you can start using it. So again, the topics that we're going to be touching on with these demonstrations: producer consumer. So as Baishuan explained this morning, consumers send out interest asking for data. Producers publishing data, listen for interest with the names that it's publishing and sends back the data. So we're going to see that in operation. Caching, forwarding nodes cache the data packets that they see pass through them in their content store. And then any interests that they see that match the names that they have stored data for in their content store, they will reply with that data. So the interest may not have to get all the way back to the producer to find the data. Validation, consumers can validate the identity of the publisher of the data, so you know where that data is coming from based on certificates, and we'll be using that today. Adaptive forwarding. So forwarders using the strategy layer can adapt their forwarding choices based on their current network conditions. And if we get to see NDN map in operation on the test bed, we will probably see adaptive forwarding reflected on NDN map. And then intermittent links, one of the demonstrations is going to show how NDN can still transfer data even without a full synchronous path from end to end. So using caching and adaptive forwarding, data can still be shared between producers and consumers even when there is not a synchronous end-to-end path. And we'll see that. Okay, so the 3 demonstrations I have planned. The first 2 will be on ONL. The first is a simple producer-consumer that's going to illustrate caching. So you'll visually be able to see that caching is taking place in the NDN forwarders. The second one's going to be a slightly more complicated producer-consumer example that's going to introduce intermittent links, and we'll see data being transferred even with intermittent links. And then the third, on the NDN testbed, we'll do an image transfer with validation. So we'll show what happens if consumers get data that they cannot validate who the publisher was. And we'll show that in operation. Okay, so when I do these ONL demonstrations, this is what you're going to see on the screen. I'm going to have a topology window here. This is what I control my ONL resources through. This shows the resources that I've selected and the interconnections that I've made. So I get to set up that topology, interconnect it, and operate it. I'm going to have a window here that's just going to monitor the file size. So the demonstration I'm going to do is going to be to transfer a set of files, and I'm going to monitor how much data has come in those files as the demonstration goes on. And then a shell window where I'm just going to be controlling the demonstration. ONL provides a rich monitoring paradigm. So I have 3 monitoring charts here. The most important one we're going to be looking at is this one up here, where I'm going to monitor the data that's going across these links. And that's going to show us when caching is going on as data is transferred across all of those links. So each of these entries on these charts is monitoring some set of hardware registers in these routers. And so in real time, as the experiment's going on, I can read the registers on these links and see how much data is being transferred. So the way this all works, I allocate a set of ONL resources. So here I have a set of end hosts around the outside, and these are just rack mount servers that I get allocated to my experiment, that I reserve and are dedicated to me. No one else is going to be using these hardware resources while I'm doing my experiment. In here I have a set of software routers. These are also rack mount servers, but they're configured with 5 1 gigabit hardware ports, and they're running a Linux operating system that we then configure as a router. And so these act as 5-port routers. I then draw my interconnections to set up the network as I want it. What I'm going to do is I'm going to organize that into NDN resources. And so here I'm going to have this set of hosts and routers. I'm going to make this my producer. I'm going to make this consumer 1. And this is NDN router 1. And so consumer 1 and producer 1 are going to use NDN router 1 as their gateway router. So any NDN interests or data they send will go through NDN router 1. Similarly here I have consumer 2 that's going to use NDN router 2, and consumers 3, 4, and 5 are going to use NDN router 3. So I organize all that into my NDN subnets, basically. We're going to pay particular attention to these 3 links, and we're going to watch the data as they go across to help us understand when caching is going on. Now if you go from this to this is the NDN topology that's really represented in my experiment. I have 3 NDN routers. I have 3 consumers here, 1 consumer here, 1 consumer there, and a producer there. So what you can see from this picture, this is what NDN sees to get an interest from here all the way over to here, it should go through all three of those NDN routers if it has to go all the way across. Okay, so this is the NDN topology that is actually implemented in our configuration. Okay, so for this first demonstration, it's going to be a simple producer-consumer. We're going to see put the producers and consumers into action. We'll be able to visually see that caching is taking place and being used. Now, underneath the covers, I'm actually using Chrono Sync to do this. Okay, so Chrono Sync is being used by the producers and the consumers to share the state of the data in their namespace. So Chrono Sync shares the changes in the namespace. So any data that has changed, the other participants in this Chrono Sync are going to learn about which names it needs to retrieve, the data for those names it needs to retrieve. Chrono Sync does not transfer any data. It just gives us the state of the namespace. Because I'm running Chrono Sync, there's going to be some artifacts in the monitoring charts, which I'll explain in a minute. Okay, so when I do this first scenario, I'm going to run my consumers starting about 20 seconds apart. Okay, when consumer 1 starts, it's going to send interests to its gateway router, NDN router 1, which is going to forward them to the producer. The producer is going to send the data back. The PIT here will tell the NDN router, oh, that data needs to go this way to consumer 1. So during this phase, we'll see data go across link 1. 20 seconds later, I'm going to start consumer 2. Its interests are going to go to NDN router 2, across link 2 to NDN router 1, but the data is already in the content store there. So it's going to return it, and the data is going to come back and go to consumer 2. So we'll see data go across link 2, but not link 1. And that will tell us caching's going on. NDN router 2 could get the data from NDN router 1. It didn't have to go all the way back to the producer. Similarly, for consumer 3, goes to NDN router 3, over to NDN router 2, where the data's already been cached because it was used when it got it to NDN router 2, or to consumer 2. So it'll come back and up to consumer 3. We'll see data across link 3, but not 2 or 1. When 4 and 5 start, they send their interests to NDN router 3. It has the data and it sends it directly back, and we won't see data going across any of the first 3 links. So this is what the monitoring charts are going to look like. So when consumer 1 starts, we're going to see this going on, and you can't read this here, but black is link 1, blue is link 2, and green is link 3. So when consumer 1 makes its request, we're going to see the data going across link 1. For consumer 2, we're going to see it going across link 2. For 3, across link 3. For 4 and 5, we're not going to see any data going across those links. Okay, these other charts show us the data and interest coming to and from each of the entities. So over here, and again, you can't read it here, but is the producer, the consumers, and each of the routers, so that when I'm building this and debugging it, I can see each individual piece. Now the artifacts I mentioned, so the Chrono Sync artifact is these bumps here. And what that is Chrono Sync is sharing information between neighbors. And so there's some more data going across the links at this point. That this is why some data is showing up on 2 and 3, because Chrono Sync is going to try and broadcast stuff out to all the neighbors to say, here's the data that I have in my data space. And so we're going to see some bumps here, but that's Chrono Sync data. Now ONL also has some monitoring artifacts. So when I sample the data, the packet counts, the packet sizes, the data sizes that are being transferred, they may come from different hardware at slightly different times. And so the timing relationship between these lines may be slightly off because they're coming from different hardware. So you can't use the ONL monitoring to be very precise about the exact timing relationship between data. but it is very good at measuring the rates of data. Okay, so let's go ahead and do the first demo. So hopefully this looks a little bit familiar from what we described. We have our topology window. Here I'm monitoring file sizes. Here I have my script queued and ready to go, and our 3 monitoring windows there. So again, this is the one that's going to be of most interest here with link 1, link 2, and link 3 to measure the data across these 3 links. I think things are better, and I'm going to plow ahead and hope for the best. So I'm rerunning my first ONL demonstration again, and I'm watching this window to tell me when it's all queued up and ready to go. And I've run it a couple of times, and I've seen it look fine, so hopefully we'll be okay. There's still a lot we have to learn, obviously, but there seems to be something that goes wrong when I start things and have it queued up and then I let it sit and wait for a long time. So I don't know if I'm losing a face and then data and interest aren't getting through or what, but it is definitely something that I will investigate. Is this one on for you? Okay. All right, so now we're ready to go again. So this is the first set where I showed you what the monitoring chart should look like. So at this point, consumer 1 has started, and we can see that we're seeing the majority of the data going across link 1. Again, this little bump down here is because of Chrono Sync sharing namespace information. This is consumer 2 starting up, and we're seeing the data going across link 2, but you can see the black line down here for link 1 is not showing much data at all, just a little few bumps, which are again related to Chrono Sync, and it's not even as big as the other one because link 1 already knows about the full namespace, so there's not a whole lot to learn. Consumer 3 now, and we see that all the data is across link 3, and links 1 and 2 are down here. So this is showing you that caching is going on. When consumer 3 asked for the data, it was getting it from here, from router 2. Nothing had to go back to router 1 or to the producer. Here we have consumer 4 making its requests, and we see no data going across links 1, 2, or 3. So it's getting all of its data from NDN router 3. And here we have consumer 5, and it acts just like consumer 4, nothing across links 1, 2, and 3. So hopefully you have a picture in your head now that the data that these guys over here are getting, consumer 3 is getting its data from the cache in router 2, consumers 4 and 5 are getting its data from the cache in router 3. Now we'll go back to the slides, and I'll tell you about the second demonstration. So in this case, we're going to do producer-consumer again, but we're going to do it over intermittent links. So in addition to what you saw in from the previous demo, we're going to retrieve data without there ever being a synchronous end-to-end path. And I'll tell you a little bit more about the details of that, but what I want you to think about is how would IP work if there was never a complete synchronous path from end to end, that some part of the path from producer to consumer was always broken. Some piece of that at every point in time was broken. You never had a path all the way through. Okay, so what I'm going to do in this experiment, this demonstration, is one link at a time will be up. And it's going to be up for 2 seconds at a time. So either link 1, 2, or 3 will be up and the other 2 will be down. So there's never going to be a complete path. I'm going to start consumers 1, 2, and 3 at the same time. So these 3 across here are all going to start at the same time this time. And then sometime later, 20 or 30 seconds, I forget, 4 and 5 are going to start. And we'll see how that operates. So again, the cycle is going to be, I'm going to bring link 1 up and have 2 and 3 down or inactive. Then I will take 1 down and bring 2 up and leave 3 down. And then 3 will be up and the other 2 will be down. So there's never a complete path across there from the producer to all the consumers. Okay? This is what the monitoring charts are going to look like for that. So when consumers 1, 2, and 3 start up, remember that these links are going to be up in 2-second intervals. We're going to see data going across link 1 for about 2 seconds, then across link 2, then across link 3, and then 1, 2, and 3, 1, 2, and 3 as we march across. And the data is going to be kind of chunked across through all the caches to get to the farther consumers. When consumer 4 starts, it's going to get all of its data from the cache in NDN router 3 by that point. And so we're going to see nothing going across the 3 links. And similar for consumer 5. All of its data is going to come from the cache of the 3rd NDN router. Now there's a little bit more of ONL monitoring artifacts that you'll see here. So when we do this link chart, we're monitoring those links every 0.3 of a second. Now what can happen during that 0.3 of a second, since this monitoring is coming from different hardware and possibly at slightly different times, during that 0.3 of a second, link 1 may be active, say, during the beginning of that 0.3, and link 2 may be active during the end of that 0.3, but they're both going to be plotted on the chart as that 0.3 of a second sample. Then when we connect the dots between neighboring samples, those lines may cross. And it's going to look like, well, at this time right in here, 1 and 2 were active. That's just an artifact of the timing of the monitoring and how we connect the dots. Okay, so you're going to see crosses like that. And again, you can't look closely at the precise timing between samples, but look at the overall pattern of the samples. Okay, well, let's go ahead and look at this. I didn't have it completely queued up, so it's going to reset itself. You'll see as it resets that the file sizes here are going to disappear. They did all get to be, I should have pointed out, they did all get to be 624 kilobytes for the last set. Move this out of the way. So what I do between each of these sets of demonstrations is I restart NFD, I make sure everything's cleared and fresh. There's nothing in the content stores to confuse us. Now it's waiting to get everything, make sure everything is completely up and running. It's going to do a little configuration. Normally I would have had this queued up all the way, but our earlier problems made me a little hesitant to do that again. While I'm waiting, I'll just take another check on the testbed. Okay, it's almost ready. So it's starting the producer right now, getting it all set up. And away we go. Okay. So consumers 1, 2, and 3 have started, and you can see these 2-second sets of data coming across links 1, 2, and 3. And if you look at the file sizes here, you'll see things progressively increase for 1, 2, and 3. We're going across nicely every 2 seconds, getting data across those 3 links. 1 and 2 have completed, and there 3 just completed. We'll see in a moment now that consumer 4 is going to start up. Here consumer 4 is getting its data, and we don't see the data coming across links 1, 2, and 3 like we did for the first 3 consumers. And then in a little bit we'll see consumer 5, and it will act the same as the others, as consumer 4 did. And here comes consumer 5. And again, we don't see the data coming across those first 3 links. So again, we're doing this without ever having a path all the way across here. and it's exercising the caching in the NDN routers down here. Okay, so the third demonstration is going to use the NDN testbed. We're going to do an image transfer with validation, and we'll see the NDN map in operation, and this is a snapshot of what we have there. So this is again going to be over our worldwide network, monitoring of that testbed at ndnmap.arl.wasl.edu. If any of you guys have your laptops out, you can go to that page and see the map as well. For this, I'm going to be using over 30 consumers, retrieving data simultaneously from 4 producers. For this, I'm going to use NDN put chunks and cat chunks. We've made some modifications to it to enhance the data validation. The producers, what you should see on the map is that the producers are not going to be overloaded by 30 times the requests or 30 times the data. Again, because of the caching, most of the consumer interests are going to be satisfied by intermediate routers. Each producer publishes 1 quadrant of an image. Each producer signs their data with their own separate key, and each consumer is going to receive all the data, but some consumers are not going to have all the certificates to validate the data from all the producers. So this would be the case where if you had requested a piece of data from a particular producer and somebody else trying to act as that producer sent you the data, it would be signed with a different key and it wouldn't match the certificate that you have, and you wouldn't want to open that data. So on my laptop then I would also run 3 consumers. Consumer 1 is going to be able to validate quadrants 1 and 3. So each of those 4 producers is producing a different quadrant of the picture. Consumer 1 can validate quadrants 1 and 3. Consumer 2 can validate 2 and 4. And then consumer 3 could validate all of them. My producers here at the WashU node, so they're hanging off the WashU node. I have AWS instances which are connecting to each of the sites in the testbed and running consumers to request the data for the images that the producers at WashU are publishing. So as my script runs, it's starting an instance at each of these sites, so you'll see them kind of progress around the world. So what you should see, though, is that we're going to run over 30 consumers, but the bandwidth coming out of WashU isn't going to be 30 times the bandwidth that we see on any of the links. The way NDN testbed displays the bandwidth is by changing the color and the thickness of a line. So red being the fastest links, and black and into the blues being the next. So the 3 consumers running on my laptop, one of them, remember, had 2 of the validation certificates, the other one had the other 2, and the third one had all 4. And so what we see here now is that my consumers have finished. This one over here, consumer 1, was able to validate these 2 quadrants, so it displayed that data. It did not have valid certificates for the data it received here, so it didn't want to look at that data. It could not verify who the publisher was. Opposite, this one, consumer 2 had the validation certificates for those 2, and consumer 3 had the validation certificates for all 4 quadrants, so it displayed the entire images. So my consumers were using the UCLA node as their gateway router. So it's hiding behind the shell window here. But what you see is that there's still some paths that are active. So what's going on there? There's no data being pulled out of the WashU node where the producers are. So here what we have is we have some sites where the consumers started late, started requesting the data late, and they're getting it out of neighbor caches. So the content stores at some of the neighboring gateway routers had the data that those nodes wanted, and so the request, the interest, never made it all the way back to WashU. And now we see that it's gone quiet, all the consumers have finished, they've gotten all the data they want, and we've seen the images come up on our screen. So this is using AWS to put instances out in the world. So I've marked also on here with these blocks where the actual AW instances are around the world. I spread my consumers out so that they were close to where these nodes are. And I was able to successfully pull data all across the testbed.
Worth the wait.
Yeah, well, I hope so. It was, so we have some testing to do, obviously, because we're not sure what exactly failed earlier. I thank you for your patience, but what I suspect happened was I set all of this up a long time in advance. So early this morning, I set up all the stuff on AWS. I had them connect to the testbed. I tried it out. Everything worked. And then I just left them there. And so I don't know if something happened during the day that they had been there a long time, that maybe some of the faces disappeared or what. But what we found was that the NFD running on each of these sites was crashing repeatedly. So it would start up, it would get a fatal error, and we're still trying to figure out what that means. And it would crash, and then it would restart, and it would continue like that. It only cleared up as soon as I killed all my AWS instances. So I'm kind of revealing ourselves to you that we still have work to do, but that's what happened. We, in a few minutes, managed to figure it out, correct it, and restart, and hopefully squeezed in some good demos for you.